All right, problem 4-72. Graph the four inequalities below on the same set of axes. So we've got four inequalities. We've got 1, 2, 3, and 4. They want us to graph them on our coordinate plane here, on our set of axes. We've got our x-axis, we've got our y-axis. All right, so first thing we need to do here is take them and get them into slope-intercept form. So looking at number 1 here, I've got 2y is greater than or equal to x minus 3. And we need to get y by itself, so we're going to divide everything by a 2. So we now end up with y is greater than or equal to, you should have 1/2 x minus 3/2. Okay. And we'll graph that in a second. Let's go ahead and just get everything ready to graph, and then we'll look at our what shape and everything that we're going to end up with here, or we'll look at parts A and B. So number 2 here, we've got x minus 2y is greater than or equal to -7. When you do this one here, we want to get y by itself. You think about different ways you could get y by itself. You could subtract x from each side and then divide everything by a -2. And if you do that, remember you got to flip your inequality. If you're not comfortable with that, then go ahead and add your 2y across, then add your 7s to each side there and divide by 2. Each one will get you the same answer. It's up to you which way you want to do it. I'm going to go ahead and just subtract my x's and then divide by the negative so that we remember the rule for flipping our inequality symbol. So we've got -2y is going to be greater than or equal to the opposite of x minus 7. To get y by itself, I'm going to have to divide by -2, in which case I'm going to have to divide everything on the other side by a -2. Now remember, when you take this and you divide by negatives on both sides, that's going to take our inequality here and it's going to flip it around. So we now have, instead of greater than or equal to, we have less than or equal to. The rest of it is y, so y is less than or equal to. We have 1/2 x, and then the negatives can cancel each other out. We have plus 7/2, which is like 3.5. So there is our second inequality. Our third one, let's do that one here in black. Let's go number 3. Well, we've already got y is less than or equal to -2x plus 6. This one's already in slope-intercept form, so there's no need to take that any farther. So and then our last one here, let's do number 4. We have -9 is less than or equal to 2x plus y. So I know y is over here by itself, or we want y over here by itself. So if we get rid of our 2x from each side, we should now have -2x minus 9 is less than or equal to y. Now if I want to rewrite that so my y is on the left side, I know a lot of people are more comfortable seeing it that way. We'd say y, and notice this is open towards y, so we're going to open it this way. It's the same thing as saying y is greater than or equal to -2x minus 9. Well, now comes the part here we're going to look to graph each of these. It says, and then we're going to look at the question, what type of polygon is formed by the solution of this set of inequalities? Write a convincing argument to justify your answer. So let's go ahead and graph them first. First thing we're going to do is just treat them like they're lines. They are all linear, and then we'll talk about the inequality symbols. Let's take our first one here. We've got, I'll do these points in red. We've got our y-intercept to be -3/2, which is like saying -1 1/2. And our slope is 1/2, so rise 1, run 2. So we're going to rise 1, run 2. Rise 1, run 2. You don't have to put every single point on there. I'm just putting them on there for this one here so that when I get my line out here. Now each of these is going to be a solid line because they all contain equal signs. Remember, if it's got equals in it, we're looking at a solid line because they are solutions to the systems. All the points on the lines will work. Let's get out our line tool. And let's start up here and let's go right down through here. That's close enough. Now, if we were going to talk about where the solutions are, we're talking about all the output values that are more than, that are going to be more than the 1/2 x minus 3/2. So when we put an x up in here, we want to get a y value that's more than that. All of these points are the points that are exactly equal to it. So if we want to talk about outputs that are greater, that would be the ones that are above it there. If we wanted to shade this, we would shade upward here. Now I'm not going to shade everything right now at this moment because I'm going to put all my lines on there first, but you can shade it lightly if you'd like to. Number 2, we've got y is less than or equal to 1/2 x plus 7/2. So let's take it and let's put our y-intercept on there. That's like saying 3.5. So 1, 2, 3.5. And our slope is the same as what we have on this one. So we're going to go up 1 over 2. Up 1 over 2. Up 1 over 2. And so on there. Just get a couple more here. So that way when I use my line tool, I can make it straight. You can probably just use a ruler. Make it easy on yourselves. Straight edge of some sort. So let's take it here, let's get out our line tool. Start up here and go this way so I can hit all my points and continue. Now with this one, we're talking about everything that's less than 1/2 x plus 7/2. So all the outputs want to be less than this line. So this one, we're looking at, we're going to be shading underneath it. And remember our first one here, just so we're good with that, we'd be going above it. So right now the shading overlap would be between these two. Let's look at the next one. Y is less than or equal to negative 2x plus 6. So our y-intercept is 1, 2, 3, 4, 5, 6, right up here. And we're going, slope, it's negative 2, so we're going to go down 2, but then right 1. Down 2, right 1, down 2, right 1. Up 2, left 1. Use my line tool, let's put it on there. There's that one. Let's go ahead and do this one here. Our y is greater than or equal to negative 2x minus 9. Then we'll look at which side that one, the first one here, I'm sorry, the third one, which one it would be shaded, which side. So let's go down to 1, 2, 3, 4, 5, 6, 7, 8, 9. We're down here. And our slope is the same, negative 2. So that means if we're going to go up 2, we have to go back 1 to the left. Up 2, back 1 to the left. 2, back 1 to the left. And let's put that line in. Let's start down here. Let's just shoot up this way. Now, with this one, we're looking at all the values that are greater than or equal to negative 2x minus 9. If we put our point on our line and or our cursor here, and we just move up for our output here, this side would be the side that would be greater. Okay, I wouldn't end up being underneath. Underneath would be less than. If you're not sure, you can take a point and plug it in to check it. But with this one, we'd be shading this way. And I'm just not shading here because you wouldn't be able to see everything on my graph because I can't make the colors really light here. This last one, y is less than or equal to negative 2x plus 6. When we were to shade that, we start here and we look for everything that's underneath it. We want the outputs that are less than this line. So if you put your cursor on the line, then you just go straight down, it'll put you on the side that you're supposed to be on. So that means that we'd be shading in here. So the overlap of all of our, of everything that we're looking at here, let's see if I can, let's use a crayon, that'll be fun. Our overlap should end up being right inside of here. This is the solution. Oops, I went out of there. Hopefully you're a better colorer than I am and you can stay within the lines. But we're going to end up right there. That is our solution. Now let's look at answering the questions below. We've got, what type of polygon is formed by the solution of this set of inequalities? That to me looks like a rectangle. So we could say a rectangle is formed by the solution set so let's write a convincing argument to justify your answer. Well, things to think about there are when we look at our slopes. Remember, perpendicular slopes, if we take them here and we multiply them, they should end up giving us a product of -1. So if we take -2 times 1/2, -2, we'll make it -2/1, times positive 1/2. When we do that, -2 times 1 would be -2. 1 times 2 is 2. That equals -1. So we know that these two sets of parallel lines are perpendicular to each other. And therefore we know that this would have to end up being a rectangle because it's a quadrilateral with 4 right angles. Now, find the vertices of the polygon. Okay, if your graph is very accurately drawn, you will be able to determine the points from the graph. If not, you will need to solve the system of equations that represent the corners of your graphs. We don't need to do that. I graphed it pretty accurately there, so we can look at our 4 points here. They should end up being, and go back and look at yours to make sure that yours ends up being the same, but you should end up with these 4 points. First one here, we should have the point 1, 4. That would be this one, go over 1 upper, that's the point 1, 4. The second point here, let's do -3, -3. So if I go back 1, 2, 3, down 1, 2, 3, that's where I'm at. Third point there be -5, 1. So back 5, up 1. And the last one we have is the point 3, 0. So those are your 4 vertices for your rectangle. If you have questions about this, or if you didn't get the same thing, maybe you want to check your inequalities or graph the equations on the calculator. I'll show you how to graph inequalities on the calculator sometime real soon, but this is the shape that you should get when you graph these 4 inequalities, and this is the overlap of all the shading. This is problem 4-72. Hope this helped. This is Mr. Boyd, signing off.